The 2008 National Electrical Code, or NEC, mandates ground fault circuit interrupter, or GFCI, protection for all pool and filter pumps, irrespective of their connection type, whether cord connected or permanently wired. This stipulation is explicitly stated in Section 680.31 of the NEC. Section 680.31 unequivocally states that all pool and filter pumps shall be equipped with ground fault circuit interrupter, or GFCI, protection for personnel. The fundamental rationale behind this requirement is to safeguard individuals from the potential hazards of electrical shock in the event of a ground fault. Ground faults manifest when electrical current deviates from its intended path, potentially flowing through unintended mediums such as the water within a swimming pool. Ground fault circuit interrupters, or GFCIs, are designed to detect these ground faults and promptly interrupt the power supply, thereby mitigating the risk of injury to individuals in or around the pool. It is crucial to recognize that this particular requirement does not extend to pumps situated within locked rooms or enclosures that are accessible exclusively to qualified personnel. Furthermore, the ground fault circuit interrupter, or GFCI, protection mandate does not encompass pumps utilized for fire protection purposes. Now let's delve deeper into the specifics of ground fault circuit interrupters, or GFCIs, and their function within electrical systems. A ground fault circuit interrupter, or GFCI, operates on the principle of monitoring the balance of electrical current flowing between the hot, or energized, conductor and the neutral conductor within a circuit. Under normal operating conditions, the current flowing through the hot conductor should precisely equal the current returning through the neutral conductor. However, when a ground fault occurs, a portion of the current deviates from its intended path and instead flows to ground. This deviation creates an imbalance between the current in the hot and neutral conductors. The ground fault circuit interrupter, or GFCI, is engineered to detect even-minute imbalances in current, typically on the order of 5 mA. When such an imbalance is detected, the ground fault circuit interrupter, or GFCI, instantaneously trips, interrupting the flow of electricity and preventing a potentially dangerous electrical shock. The speed at which a ground fault circuit interrupter, or GFCI, trips is critical. It is designed to interrupt the circuit within a fraction of a second, typically around 20 to 30 milliseconds. This rapid response time significantly reduces the duration of exposure to electrical current, minimizing the risk of severe injury or even death. Now let's examine the installation of ground fault circuit interrupters, or GFCIs, in pool and filter pump circuits. According to the 2008 National Electrical Code, or NEC, all pool and filter pump circuits, regardless of whether they are cord connected or permanently wired, must be protected by a ground fault circuit interrupter, or GFCI. This means that the electrical circuit supplying power to the pump must include a ground fault circuit interrupter, or GFCI, device, either in the form of a ground fault circuit interrupter, or GFCI circuit breaker, or a ground fault circuit interrupter, or GFCI receptacle. In the case of a permanently wired pump, the ground fault circuit interrupter, or GFCI, protection can be provided by a ground fault circuit interrupter, or GFCI circuit breaker installed in the electrical panel that serves the pump circuit. Alternatively, a ground fault circuit interrupter, or GFCI receptacle, can be installed upstream of the pump, providing ground fault circuit interrupter, or GFCI, protection for the entire circuit. For cord-connected pumps, the ground fault circuit interrupter, or GFCI, protection is typically provided by a ground fault circuit interrupter, or GFCI, receptacle into which the pump is plugged. These ground fault circuit interrupter, or GFCI, receptacles are commonly found near swimming pools and other outdoor locations where electrical equipment is used in close proximity to water. It is essential to ensure that the ground fault circuit interrupter, or GFCI, device is properly installed and functioning correctly. Regular testing of the ground fault circuit interrupter, or GFCI, is recommended to verify its operational status. Most ground fault circuit interrupter, or GFCI, devices have a test button that, when pressed, simulates a ground fault condition, causing the ground fault circuit interrupter, or GFCI, to trip. If the ground fault circuit interrupter, or GFCI, fails to trip when the test button is pressed, it should be replaced immediately. Furthermore, it is important to select the appropriate ground fault circuit interrupter, or GFCI, device for the specific application. Ground fault circuit interrupters, or GFCIs, are available in different classes, each designed for different levels of protection. For pool and filter pump circuits, a class of ground fault circuit interrupter, or GFCI, is typically required. A class of ground fault circuit interrupter, or GFCI, is designed to trip when a ground fault current of 6 mA or more is detected. Now, let's address the exceptions to the ground fault circuit interrupter, or GFCI, protection requirement for pool and filter pumps. As previously mentioned, the 2008 National Electrical Code, or NEC, provides two exceptions to the ground fault circuit interrupter, or GFCI, protection mandate for pool and filter pumps. First exception applies to pumps located in a locked room or enclosure that is accessible only to qualified persons. This exception recognizes that in certain commercial or industrial settings, pool and filter pumps may be installed in restricted access areas where only trained and authorized personnel have access. In such cases, the risk of accidental contact with electrical hazards is significantly reduced, and the ground fault circuit interrupter, or GFCI, protection may not be necessary. However, it is crucial to ensure that the locked room or enclosure is indeed secure and that access is strictly controlled. The second exception applies to pumps used for fire protection purposes. This exception acknowledges that fire protection pumps are essential for safeguarding life and property in the event of a fire. The reliability of these pumps is paramount, and the potential for nuisance tripping of a ground fault circuit interrupter, or GFCI, could compromise their ability to function when needed most. Therefore, the 2008 National Electrical Code, or NEC, exempts fire protection pumps from the ground fault circuit interrupter, or GFCI, protection requirement. However, it is important to note that this exception only applies to pumps specifically used for fire protection purposes and not to other types of pumps that may be present in the same facility. In conclusion, the 2008 National Electrical Code, or NEC, mandates ground fault circuit interrupter, or GFCI, protection for all pool and filter pumps, regardless of their connection type, with the exception of pumps located in locked rooms or enclosures accessible only to qualified persons and pumps used for fire protection purposes. This requirement is intended to protect people from electrical shock in the event of a ground fault. Ground fault circuit interrupters, or GFCIs, are designed to detect ground faults and shut off the power before anyone can be injured. It is essential to ensure that ground fault circuit interrupters, or GFCIs, are properly installed and functioning correctly. Regular testing of the ground fault circuit interrupter, or GFCI, is recommended to verify its operational status. Furthermore, it is important to select the appropriate ground fault circuit interrupter, or GFCI, device for the specific application. By adhering to these guidelines, you can help ensure the safety of individuals in and around swimming pools and other water features. Now let's broaden the discussion and include more information about swimming pool pump requirements that are important to consider. Firstly, let's talk about the bonding requirements. The NEC mandates that all metal parts of a swimming pool, including the pump motor, must be bonded together to create an equipotential plane. This bonding helps to minimize voltage gradients in the pool area, reducing the risk of electric shock. The bonding conductor must be sized according to NEC Table 250.122, based on the size of the circuit conductors supplying the pump motor. Secondly, it's also important to discuss wiring methods. The wiring methods used to supply power to the pool pump must comply with the NEC requirements for wet locations. This typically involves using liquid-tight flexible metal conduit, or LFMC, or rigid polyvinyl chloride, or PVC conduit to protect the wiring from moisture and corrosion. The conductors must be insulated with a moisture-resistant insulation type such as type THWN or THHN. Thirdly, it's important to cover overcurrent protection. The pool pump motor must be protected by an overcurrent protection device such as a circuit breaker or fuse. The overcurrent protection device must be sized according to the motor's nameplate rating and the NEC requirements for motor protection. It is important to choose an overcurrent protection device that is specifically listed for motor protection to ensure that it will provide adequate protection against overloads and short circuits. Fourthly, let's talk about disconnect switches. A disconnect switch must be installed within sight of the pool pump motor to allow for safe disconnection of power during maintenance or repair. The disconnect switch must be rated for the voltage and current requirements of the pump motor. It is also recommended to choose a disconnect switch that is suitable for wet locations to prevent corrosion and ensure reliable operation. Fifthly, you must follow the requirements for underwater lighting. If the swimming pool has underwater lighting, the lighting fixtures must comply with the NEC requirements for underwater lighting. This includes using listed underwater lighting fixtures, providing ground fault circuit interrupter, or GFCI, protection for the lighting circuit, and bonding the metal parts of the lighting fixtures to the pool's bonding grid. Sixthly, surge protection is also crucial. It is recommended to install a surge protective device, or SPD, on the pool pump circuit to protect the pump motor from voltage surges caused by lightning or other electrical disturbances. The surge protective device, or SPD, should be located as close as possible to the pump motor and must be properly grounded. Seventhly, you must meet the requirements for the location of electrical equipment. Electrical equipment such as receptacles and switches must be located at least 5 feet away from the inside wall of the pool, unless they are specifically listed for use in wet locations. This requirement helps to prevent accidental contact with electrical hazards by people in or around the pool. Eighthly, you must ensure proper grounding. The pool pump motor must be properly grounded to provide a path for fault current to return to the source. The grounding conductor must be sized according to NEC Table 250.122, based on the size of the circuit conductors supplying the pump motor. It is also important to ensure that the grounding electrode system is properly installed and connected to the electrical system. Ninthly, it's also important to consider energy efficiency. When selecting a pool pump, it is important to consider its energy efficiency. Energy-efficient pumps can save a significant amount of money on electricity bills over the life of the pump. Look for pumps that are labeled with the Energy Star logo, which indicates that they meet certain energy efficiency standards. Tenthly, local codes and regulations also matter. In addition to the NEC requirements, it is important to check with the local authorities to determine if there are any additional codes or regulations that apply to swimming pool electrical installations. Local codes may have more stringent requirements than the NEC, so it is important to comply with all applicable codes and regulations. Proper installation and maintenance of swimming pool electrical equipment is essential for ensuring the safety of swimmers and preventing electrical hazards. It is always recommended to consult with a qualified electrician when installing or maintaining swimming pool electrical equipment. Ignoring the electrical aspects of swimming pools can lead to tragic accidents, underlining the importance of adhering to safety standards and professional guidance. The information provided serves as a general guideline and should not be considered a substitute for professional electrical advice. It is crucial to consult with a licensed electrician for specific guidance and compliance with local electrical codes. Remember, safety always comes first, especially when electricity and water are involved. By understanding the requirements outlined in the National Electrical Code, or NEC, and other applicable regulations, homeowners and professionals can contribute to safer swimming pool environments.